Welcome everyone, lecture number 25. Today I'll discuss Introduction to Fourier Transform. So Fourier Transform is very useful topic and it is very important tool for image processing. Basically it is used to decompose an image into its sine and cosine components, and it is also used in the analysis of an image, in filtering of an image, and in image reconstruction, as well as in image compression. So it is basically of two types: infinite Fourier transform and finite Fourier transform. So today I'll discuss infinite Fourier transform in this lecture. Okay, so infinite Fourier transform. Basically infinite word is not used before before Fourier transform. If we say only Fourier transform, then it obvious that it is infinite Fourier transform. So I am putting this into a bracket. So the definition of infinite Fourier transform starts when the function satisfies some conditions. So if we have some function, say fx, okay, and it is defined on an interval, say minus infinity to minus plus infinity, and it is piecewise continuous, okay, piecewise continuous on this interval, as well as absolutely integrable. Absolutely integrable means its absolute value is integrable in this interval. We have these three conditions. If the function satisfies all these three conditions, then Fourier transform of this function fx is defined as f of fx. We write f of fx. F means Fourier transform, and it is defined as minus infinity to plus infinity e raised power I p x fx dx, and the result that we obtained is a function of p, so we'll denote this by fp. Okay, so we have here on the left hand side we have function of x, and on right hand side we have function of p. We can use some different combination, or we can give them some name, different names to x and p, like we can call x as like frequency, and p can be taken as time. So here we have a function of x which denotes the frequency, and here we have function of p which denotes the time. So you may have different combinations, different names for those combinations in engineering and physics. Okay, in acoustics we can call them as if we talk about, if we are studying acoustic field or we are in acoustic, then in acoustic we can call them as telecommunication and radio, right? Telecommunication and radio. So we have, in this way we have different combinations and we call them by different names. So in general, x and p, we use x and p as abstract entities and give them a physical meaning when an illustration seems called for, right? So you can remember these two symbols like x is always, x and p always have inverse dimensions as time and frequency, and the product px, because x and p have the reverse dimensions, so it is a dimensionless number. Okay, it is a dimensionless number. Always you can memorize, as I said before, that you can take in x as time and p as frequency. So time and frequency always have reverse units, so that's why p and x have the product of p and x has no unit. It is a dimensionless number. So I have told you that f fx, f of fx is the Fourier transform of the function fx, right? So fx, what is fx called simply? So fx simply is called inverse Fourier transform of fp. Just like you have studied like Laplace transform and inverse Laplace transform. जैसे किसी भी फंक्शन fx का लाप्लास ट्रांसफॉर्म आप fp से डिनोट करते हो, और fp को हम कहते हैं, if we have Laplace transform of f x is fp, then fx is called inverse Laplace transform of fp. इसी तरह से fx अगर fx आप fx का फोरियर ट्रांसफॉर्म ले रहे हो, उसको डिनोट कर रहे हो fp से, तो अगर आप fp का इनवर्स फोरियर ट्रांसफॉर्म लोगे तो दैट इज डिनोटेड बाय fx. ओके, so how to find the inverse Fourier transform of the function fp? So there are some conditions that the function has to satisfy, this function has to satisfy those conditions, then only we can find the inverse Fourier transform of this function, and those conditions are called Dirichlet conditions. Dirichlet's conditions. So number one condition is fx should be defined in interval say minus L to plus L. ठीक है? And fx and its derivative, first derivative, they are piecewise continuous. Piecewise continuous in this interval. And third condition is function fx is periodic with period say 2L. So if we have fp is Fourier transform of fx, and if fx satisfies Dirichlet conditions, I'm using this form, short form for Dirichlet conditions, in every finite interval, in every finite interval, say minus L to plus L, and further, if function fx is absolutely integrable also, integrable in this interval, then at every point of continuity of fx, at every point of continuity of fx, fx is equal to 1 upon 2 pi minus infinity to plus infinity fp e raised power minus I p x dp. This is the formula to find inverse Fourier transform of the function fp. We have some other forms also for finding the inverse Fourier transform as well as Fourier transform. Those forms are number one, Fourier transform of any function fx is also defined as and denoted by fp. It is also defined as 1 upon square root of 2 pi minus infinity to plus infinity e raised power I p x fx dx. इससे पहले जो मैंने आपको फॉर्मूला बताया है उसमें हमने यहाँ पर 1 अपॉन स्क्वायर रूट ऑफ 2 पाई यूज नहीं किया है, लेकिन आप इसमें 1 अपॉन स्क्वायर रूट ऑफ 2 पाई भी यूज कर सकते हो. तो अगर आप ये फॉर्मूला यूज कर रहे हो तो इनवर्स फोरियर ट्रांसफॉर्म फाइंड आउट करने का फॉर्मूला ये हो जाता है माइनस इन्फिनिटी टू प्लस इन्फिनिटी ई रेज पावर माइनस आई पी एक्स एफ पी डी पी. ओके, सेकेंड फॉर्म है जिसमें हम फोरियर ट्रांसफॉर्म किसी भी फंक्शन का फाइंड आउट करते हैं तो हम उसको हमेशा एफ पी से ही डिनोट करेंगे, बट जो फॉर्मूला हम यूज करेंगे उसमें थोड़ा सा चेंज ये है कि वहां पर स्क्वायर रूट ऑफ 2 पाई था, यहाँ पर ये केवल 1 अपॉन 2 पाई है. ये है तो केवल कांस्टेंट का डिफरेंस है इन फॉर्मूलों में, बाकी इंटीग्रेशन इज सेम. ओके, एंड sorry, here we have negative sign, and the value of fx is, that is inverse Fourier transform, is defined as 1 upon 2 pi minus infinity to plus infinity. Here we have IPX positive. The value is positive. FPDP. Here if it is positive then you have negative sign here. Here it is negative then you have positive sign here. Okay. Third form is Fourier transform of any function fx is defined as 1 upon square root of 2 pi. The formula is similar to the first form, but the difference here is that here we have negative IPX fx dx, and the value of fx, that is inverse Fourier transform, is 1 upon square root of 2 pi. You can guess what is inside the integration. Yes, it is positive now. FP dp. So generally in most of the cases this form is used in questions. Okay. Let's take one example to understand this transform, how to find Fourier's transform. So let me take one example. Find the Fourier transform of fx. Fx is defined by 1 for mod x less than a and 0 for mod x greater than a. Hence evaluate number 1. We have to evaluate the value of this integral using this transform as well as the value of this integral. Okay, so let's start. We are given the function fx, which is defined as 1 for mod x less than a and 0 for mod x greater than a. What is the meaning of mod x less than a? You all know, means x lies between minus a and plus a. And what is the meaning of mod x greater than a? It means that x is less than minus a or x is greater than a. So by definition of Fourier transform of any function fx is defined as integral minus infinity to plus infinity e raised to the power IPX fx dx. So we divide this limit into minus infinity to minus a. Okay. Then minus a to plus a. And then a to infinity. So here we have for mod x greater than a, that is whenever x is less than minus a, that is from minus infinity to minus a, the value of fx is 0. So this integration is 0 and this integration is also 0. We have only this minus a to a e raised power IPX. We put 1 in place of fx, so we have only dx. So integrating it, we'll get Fourier transform of fx as 1 upon ip e raised power ipx, because integration is with respect to x, so ip will be constant. Okay, so its value is e raised power ipa minus e raised power minus ipa. So this is the formula of 2i sin pa. So I will cancel with this I. So this is 2 sin PA divided by P. Okay, it's a Fourier transform. Now, because we have to find the value of this integral, okay, and our answer is coming in terms of sin PA upon P, and this is also sin PA upon means we have to take the inverse Fourier transform. By using inversion formula, this is nothing but FB. Okay, अब हम इसका इनवर्स फोरियर ट्रांसफॉर्म लेंगे. तो इनवर्स फोरियर ट्रांसफॉर्म का फॉर्मूला, क्योंकि मैंने आपको फोरियर ट्रांसफॉर्म का फॉर्मूला जो मैंने यूज किया है वो ये यूज किया है, तो इसके लिए जो इनवर्स फॉर्मूला है वो ये है. ओके, तो मैं ये यूज करूंगी. एफ एक्स इज इक्वल टू 1 upon 2 pi minus infinity to plus infinity, and we put the value of fp here, 2 sin pa whole divided by p and multiplied by e raised power minus ipx dp, है ना. ओके ओके, so we have we open the e raised power ipx. ओके, एंड 2 पाई को हम इधर ले जा सकते हैं, minus infinity to plus infinity, sin pa, and 2 can also come outside, cos px minus I sin px dp, क्योंकि e raised power I थीटा की वैल्यू होती है माइनस आई थीटा की cos थीटा minus I sin theta. By using this formula, we have opened this. This implies 2 pi f x is equal to we can divide the integral into two parts. One part contains this portion and another part contains this into this portion. Okay, and 2 will cancel with this 2. So we have here integration minus infinity to plus infinity sin pa cos px whole divided by p, sin pa cos px whole divided by p, minus I will come outside, and sin pa sin px whole divided by p, sin pa sin px whole divided by p, and dp, sorry, Yes, it is dx. Now, because on left hand we have real part and this is imaginary part, so we can compare. So comparing real parts and imaginary parts, comparing real and imaginary parts both side, क्योंकि हमें जो इंटीग्रेशन इवेलुएट करना है उसकी वैल्यू है साइन पी ए कॉस पी एक्स होल डिवाइडेड बाय पी डी एक्स, इसलिए हम यहाँ कंपैरिजन कर रहे हैं। तो रियल पार्ट की वैल्यू, रियल इंटीग्रल की वैल्यू कितनी आएगी, इसकी वैल्यू आएगी पाई एफ एक्स, और पाई एफ एक्स तो आपको गिवन है तो आप उसमें मल्टीप्लाई कर सकते हो पाई का, तो इट वुड बी पाई फॉर मॉड एक्स लेस देन ए and 0 for mod x greater than a. Okay, this is the value of this integral. And for second जो पार्ट हमें प्रूफ करना है उसमें साइन p अपॉन p है। इफ यू नोटिस, तो हम ऐसा कर सकते हैं कि अगर हम इस इक्वेशन में x की वैल्यू 0 पुट करें और a की वैल्यू 1 कर दें, क्योंकि हमारे पास साइन p अपॉन p है यानी a 1 है, ओके, और x नहीं है, तो x को 0 रखने पर if we put x is equal to 0, in this equation number 1, both side, and a is equal to 1, then what we will get, sin p over p, and cos 0 is 1, so the integration will be now with respect to p, and on right hand side we have when you put 0, the value of f0 is pi, so it would be pi, okay, and because we have here 0 to infinity, so you can because this is a even function, so you can write this as 2 into 0 to infinity sine p over p dp is equal to pi. So the value of this integration is pi by 2. Okay, so this is how we evaluate this integral. I'll discuss more questions on this infinite Fourier transform in my next lecture. Thank you very much for watching the video, and if you like my lecture you can press the like button, share my video, as well as you can subscribe my channel. Thank you so much.